Hi, welcome to another Level 3 probability distributions table. We're going to chat about the mean and expected value. A statistic is a number calculated based on a sample. A parameter is a number based on the entire population. And when we analyse distributions, the most common parameters we use are the mean and standard deviation. We're going to chat about the mean in this video. Now, the mean is given a symbol called mu, the Greek letter mu. It is a measure of central tendency. It's often referred to as the expected value of x and written as E bracket x, and we say E of x. So mu is equal to E of x. All right, here's our example for the video. The following data shows the results of a quick test out of 6 marks for 20 students in Mr. Pythagoras' mathematics class. We're going to place these results into a probability distribution table. How have we done that? Well, 2 of the students out of 20 scored 0 marks. So 2 out of 20 is equivalent to the probability of 0.1 or 10%. So in the table, the 0 has a probability of 0.1. Just like 7 students out of 20 scored 4 marks, that's equal to a probability of 0.35 or 35%. So our table shows the probability of getting 4 is 0.35. All right, so from our table, we can draw a probability distribution graph. Notice on the y-axis, we have the probability, and on the x-axis, the outcome of happening. So the probability of getting 3 marks in the test is 0.2 or 20%. All right, we're going to work out the mean or the expected value of x from the table, or even from the graph if we had to read off the graph. To do that, here's the formula we're going to use. It's on your formula sheet, and we're going to show you how to use it. We're going to take each of the x values and multiply it by the probability, and then we're going to sum them all up. This symbol means to sum up. Sigma is the capital sigma, and it means to sum everything up. So we're going to go 0 times 0.1, 1 times 0.15, 2 times 0.05, 3 times 0.2, 4 times 0.35, 5 times 0.05, and 6 times 0.1. And then we're going to take all of these results and sum them up to get a mean or expected value of x of 3.1. Now we can do it a very quick way by doing it all in one go on the calculator. So our mean or expected value of x is 3.1 for the test. The average mark is 3.1 out of 6. All right. Here's example number 2. A non-for-profit charity holds a raffle and decides there will be no profit from the raffle. So that means the expected value or the mean will be 0. So E of W is going to represent the winnings, is going to be 0. So notice we're not using E of X, we're using E of W. So it doesn't really matter what letter we use in context. We're going to show that E of W is 0 for the following distribution table. Now notice this minus 2 here. This represents the winnings. And that means people win minus 2. So they lose $2 because they pay $2 for the ticket and they don't win the prize, so they lose. And the probability of this happening is 0.97. This must be first prize. They've paid their $2 for the ticket, so I assume the first prize is $120. And they lose their $2 ticket, but they win first prize to get a total winnings of $118. The probability of this happening is 0.01, so 1% happens. This is probably second prize, $50 minus the $2 ticket, so the winnings is $48. And this is third prize, probably $30 minus 28 means their winnings is $28. So we're going to calculate E of W, which is the same as E of X, and that is going to be 118 times 0.01 plus 48 times 0.01 plus 28 times 0.01 plus the minus 2 times 0.97. And if I grab my calculator and work that out, that gives me E of W is equal to 0. So the average expected winnings from this raffle is 0. So we've made no profit from the raffle. Everything we've come in to the raffle has gone back out again. Right, well that's us for the video, so thanks so much for watching.